Okay, so ini saya just go through back what we already learned on properties of sufficient statistic. Okay, so actually we already discussed about theorem. Okay, so you have theorem Rao-Blackwell theorem. Okay, so actually the point here is to find uniformly minimum variance and risk estimator. So the same thing, kita dah ada joint probability function. So we split into two parts. So the first part is depend on theta. The other part which is does not depend on theta. So itu kita apply for factorization theorem. So when we mention about Rao-Blackwell, okay. So Rao-Blackwell theorem, so you have Y1 is a function of sufficient statistic. And then Y2 ni we consider is not a function of Y1 alone. Maksudnya ada lagi satu function dia. So, but Y2 ni unbiased estimator. Maksudnya expected value of Y2 is equals to theta. Okay. So, we define statistic phi Y1, expected value of Y2 given Y1. Okay, so this statistic phi Y1 ni is also a function of the sufficient statistic and it is also unbiased estimator. Dan kalau kita compute variance phi Y1 ni less than variance Y2, then we call phi Y1 tu adalah uniformly minimum variance unbiased estimator. Okay, so other than Kramer-Rao lower bound that you already learned during the previous yang awal tu lah ya, dalam teknik macam tu. Okay, so alternatif lah untuk cari unbiased minimum variance estimator. So actually we restrict to the function of the sufficient statistic. Okay, and then find lah dia punya ni. Okay, relationship between function of the sufficient statistic dengan MLE. So normally kalau kita ada a unique MLE theta head exists, maksudnya okay, theta head tu must be a function of the sufficient statistic. Okay. So then it comes theorem 2.3 ni. Okay. So 2.3, if a sufficient statistic Y1 for theta exists and maximum likelihood estimated theta head of theta also exists, then theta head is a function of sufficient statistic. Okay, so ini kita dah buktikan sebab kita punya tu sama sebab dia punya apa? Dia punya likelihood function tu L and G as function of theta are maximized simultaneously. Okay. Okay, so again, you have this one. You want to show that MLE from a Poisson distribution having parameter theta is a function of the sufficient statistic. So kita dah derive dia punya Poisson distribution. So you find your likelihood function and then you set ln L theta, differentiate with respect to theta, and then you get your MLE. Okay. Next step, kita bentukkan the same thing, likelihood function, tapi kita gunakan factorization theorem. Kita cari apa dia punya sufficient statistic. So again, theta head kita S bar, tapi S bar can be written as summation Si over N. So that's, sebab tu kat sini saya gantikan T over N. So that means S bar is the function of sufficient statistic. Okay. So the same thing here. So this one pun you have normal mean zero variance theta. So you want to show that summation Si square is a sufficient statistic. So bentukkan dia punya likelihood function dia. Okay. So you have exponential negative summation Si square over 2 theta. So kita akan splitkan which one is your Hx, which one is your G. So Hx ini je 1 over square root 2 pi. Okay. So yang ada theta kita sekalikan. So that means your T is just summation Xi square. Okay, bukannya kamu ambil T sama dengan negatif So just T summation Xi square. Okay, then find the expected value again lah. Sebab kita ada normal, mean zero, variance theta. So mean zero, your mu is equals to 0, your sigma square is equals to theta. So you want to find the expected value. So again, summation Si square, so X1 square, semua tu. Okay, sebab kita punya, okay, macam mana kita dapat this one? Sebab kita punya apa? Variance X is equals to theta. So variance adalah EX square minus EX and then squared kan. So this one is 0 because you have normal 0 theta. So of course lah kau punya ni kamu akan dapat EX square is equals to theta. Okay, ini sama juga macam soalan dalam test. Okay. So you have n terms, so n theta. Okay, so this one again kita dapatkan. Okay. So we have this one, you want to find sufficient statistics. So Tx in this case is summation xi square. Kita tengok yang part C tu. Okay, part C, you want to find your theta head using MLE. So again, we already have your likelihood function, so just differentiate. So theta head summation xi square over n. Okay. So again, your theta head here. So expected value of theta head is equals to expected value of summation xi square over n. So it is unbiased estimator. Okay. Ini baru example yang baru. Okay, so this one example 2.6 eh. Okay, ini saya just dalam nota kamu dalam nota tu ke nombor dia. Okay, exercise 2.9 ikut saya tukar kat situ. Okay. So again, this one you have x1, x2 is a random sample of size 2 from a distribution having PDF this one. Okay, ni dia punya jalan kerja dia panjang sikit eh. So saya akan explain. So kamu dengar dan cuba fahamkan. Okay. After dah balik cuti raya nanti, cuba buatlah balik tengok. Okay. So again, you want to find the joint ini. Sorry ya, tertinggal keywords dia adalah independent random sample. Okay. So again, this one is exponential distribution. So you have 1 over theta, exponential negative x over theta. Okay. So x lies from 0 up to infinity, theta again lah, theta greater than 0. So again, kat sini kita nak dapatkan find the joint PDF of the sufficient statistic. Okay, the joint PDF of the sufficient statistic. So it gives to you is y1 is equals to x1 plus x2, and then also y2 is equals to x2. Okay. So ini kiranya masing-masing kita ada fx1 theta is 1 over theta exponential negative x over theta. Fx2 pun is the same thing. Ini x1 ya. 1 over theta exponential negative x2 over theta. So sekarang kita nak dapatkan joint PDF of y1 dengan y2. Maksudnya kamu nak dapatkan G y1 y2. Okay. So this one you need to reflect back what you already learned in mathematical statistics. Yang third year tu mungkin masih ingat lagi. Yang final year tu saya rasa macam dah tak ingat dah lah. Okay, so this one is your bivariate PDF bivariate PDF. So again, kalau kita ada ni, kita akan pakai Jacobian transformation. Okay, saya pernah ajar this one. So kamu ada dalam bivariate, which is we use the method of transformation. Okay. So sekarang kita tengok macam mana kita nak construct dia punya joint PDF. Maksudnya kita nak dapatkan G, Y1, Y2. Tapi kamu ada Y1 sama dengan X1 plus X2. Y2 is equals to X2. Okay. This one Okay. So let's say your Y1 is equals to X1 plus X2. Y2 is equals to X2. So that means X1 kamu adalah Y1 minus Y2. So ini katakan first. X2 is equals to Y2. So we apply Jacobian transformation. So we get dx1 over dy1. Dia punya method kaedah dia. dx1 dy2, dx2 dy1, dx2 dy2. So katakan saya lengkapkan. So dx1 y1, we have 1 minus 1 So dx2 dy1 0. So this one 1. Okay. So dapatkan dia punya determinant. So it just 1. So kita gunakan Jacobian transformation. Okay, so since we have independent distribution, so kita dah ada ni So kita ada fx1, x2. So maksudnya ini adalah bivariate untuk x1, x2. So since exponential distribution tu adalah independent, so kamu boleh multiply. So kita ada 1 over theta square exponential negative x1 plus x2 over theta. Okay, sebab masing-masing dah ada dia punya PDF tadi, which is this one Ni. Okay, and then 1 over theta exponential negative x2 over theta. So ini darab ni, kuasa dia kita tambah lah. So 1 over theta square exponential negative x1 plus x2 over theta. Okay, so now kita nak dapatkan joint PDF. Okay, joint PDF for y1, y2. So we apply method of transformation. Okay, method of transformation. Maksudnya kamu dah ada joint PDF kamu ni for x. So sekarang kita gantikan. X1 adalah Y1 minus Y2. X2 kamu adalah Y2. So divide by theta. Darabkan dengan Jacobian dia. Tapi Jacobian dia 1. So that's why lah. Tak letaklah 1 Darabkan. So kamu akan dapat this one. So this is your joint PDF. Okay, for Y1, Y2, which is 1 over theta square exponential negative Y1 over theta. Okay. So and then you write lah what is your range dia. Okay, because kita punya nilai, okay, kita punya X tadi, range dia adalah 0, less than X1, less than infinity. Okay, kalau X2, 0, less than X2, less than infinity. Sebab dia individual tadi. Okay. So kalau nak letak range dia, kamu ingat balik lah. Kalau X1 apa tadi? Okay, Y1 minus Y2 less than infinity. But it's the same thing if you have Y2 less than Y1 less than infinity. So kita gantikan X2. X2 is just Y2 lah. 0 less than Y2 less than infinity. Okay, itu dia punya range dia. Sebab kalau kita belajar dulu, when you have your joint PDF, you need the range lah. Range untuk kita integrate and so on lah ya. Okay, that is your joint PDF. So kita dah jawab yang, sorry kalau saya padam habis dah. Okay, kalau kita, that's mean kita dah solve dia punya first question. So first question, you want to find the joint PDF of the sufficient statistic. Okay. So now second question. Second question, you want to show that Y2 is unbiased estimator of theta and have variance theta square. Okay, so sekarang kita nak dapatkan Y2. Sekarang ni kita cuma ada bivariate je. Bivariate PDF which is Y1, Y2. Kamu tak ada Y2. So how you want to get Y2? Using your marginal concept. Okay, concept marginal. So function gy2, that means you will integrate with respect to y1. Okay, kita masukkan tadi gy1, y2, kamu punya join PDF tadi. This one. Okay, range dia y1. Tadi y1 dia. Ya, y1 dia kita dah ada tadi. Okay, so that is your range. Okay, so that means we will integrate for y1 is from y2 up to infinity. Punya range ni y2 up into infinity. Okay, selesaikanlah. You have 1 over theta square, integrate exponential negative y1 over theta. Okay, integrate with respect to y1. So selesaikan dia punya kamiran. And last you have this one. Okay, so this is marginal function for y2. Okay, kenapa kita dapatkan marginal function for y2? Because you want to show that expected value y2 is unbiased estimator of theta. So that means you want to show that expected value of y2 is equals to theta. So macam mana kita dapatkan expected value of y2? Is y2 times your gy2. Maksudnya, okay, ey2 integrate y2 times gy2 lah. Okay, dy2. Okay, which is this one lah. Okay. So expected value of y2. So y2 times your marginal function. So kita gantikan y2 over theta, exponential negative y2 over theta, dy2. Okay, again. Theta tu kita boleh faktorkan 1 per theta. So selesaikan kamiran kat dalam ni. Okay, you need integration by parts. Maksudnya, you need to be expert in integration by parts for exponential distribution because this kind of distribution memang always lah kita tanya, always kita guna. Okay. So that's mean kita selesaikan. Okay, negative theta ambil lah u apa. That's mean kamu ada u equals to y2. dv kamu ada exponential negative y2 over theta. So dapatkan du, dapatkan dv. Masukkan dalam formula integration by part. Okay, selesaikan. You get theta. Okay, nanti kamu check ya. Kamu tengok balik macam mana saya dapat dia punya value. Okay. So you have expected value y2 is equals to theta. So in this case, y2 is unbiased estimator of theta. Okay, so that is the first part lah, expected value of y2. Okay. Lepas tu dia minta pula variance y2. Okay. So if you want to find your variance, what you need is to find your expected value of y2 square minus ey2. Lepas tu square kan. That one. Okay. So, okay, now kita dapatkan dulu expected value of y2 dah ada theta. So, expected value of y2 square. Okay, same. Dia punya apa? Ni je lah dia punya integration tu, jangan salah integrate je lah dia punya tu. So, kamu ada again y2 square times your PDF tadi. PDF for y2 tadi. 1 over theta exponential negative y2 over theta dy2. So again, faktorkan y1 over theta, selesaikan dalam tu integration by parts. Okay, tapi kena double check balik lah, tengok betul ke tidak. Okay, so now at last tu saya sampai kat sini. Okay, so kita gantikan infinity. So 1 over exponential up to approaching infinity, that terms will become 0. Okay, so 0 minus this value lah, minus, so that's why positive 2 theta square. Gantikan y2 to 0, exponential to power 0 is equals to 1. So I get expected value of y2 square is 2 theta square. Okay. Okay, you already have expected value of y2. Expected value of y2 square. Now, what is your variance? So variance gantikan balik dalam formula. EY2 square minus EY2 and then square kan. Okay, you get theta square. So that is your variance. Okay, sebab dia punya soalan tadi show that y2 is unbiased estimator of theta. And then you get the variance is theta square. So that means you already know the answer is theta square. So just to make sure how you get your theta square. Okay, this on dia punya integration lah. Okay, part C ni baru dia nak apply Rao-Blackwell theorem. Okay, Rao-Blackwell theorem tadi kita ada dua function tadi kan. Okay, and then kita ada join sufficient static, dia punya join apa? Bivariate PDF dia y1, y2. And then we already show that y2 is unbiased estimator. So kalau kita ada this one, expected value of y2 given y1 equals to phi y1. Okay, kita nak provekan this one. So kita nak provekan and then find sama ada dia punya tu uniformly minimum variance unbiased estimator ataupun tidak. So expected value of y2 given y1 is equals to phi y1. Okay, apa dia punya conditional probability. So fy2 given y1. Join kamu fy1 fy2 tadi divide by marginal fy1 pula. So tadi kita dapatkan marginal fy2. So now you need to find what is your marginal fy1. Okay, sebab tu panjang ni soalan dia ni. Okay, fy1 that means kamu integrate with respect to y2. So masukkan balik dia punya bivariate PDF tadi. Integrate with respect to y2. Range kamu from 0 up to y1. So selesaikan. Okay. Okay, so selesaikan dia punya integration dia, you get this one. Okay, you have y1 over theta square exponential negatif ya kat depan ni. Dia ada negatif ni. Tak nampak dia sebab dah sekali dengan tu. So negatif y1 over theta. Okay, semua ni dah ada negatif ya sebab saya punya tu kempau. Oh, besar pula. Okay. Okay, nampak ya? Okay. So that is your fy1. Okay, now kita nak dapatkan conditional probability dulu. So fy2 given y1. Kamu dah masuk tadi bivariate kamu. 1 over theta square. Exponential negative y1 over theta. Dividekan dengan dia punya marginal ni. Okay, cancel out. Yang kamu ada, ini je. 1 over y1. Okay. So now kamu dah dapatkan expected value. So expected value y2 given y1. So y2 darabkan dengan fy2 given y1 dy2. Okay. So ini adalah 1 over y1. So y2 kamu punya range from 0 up to y1. So selesaikan kamu ada ini. So itu dia punya expected value of y2 given y1. Okay. And now, so kita nak dapatkan variance phi y1. Okay, phi y1 kita adalah y1 over 2. Okay, so variance phi y1 adalah variance y1 over 2. So you will have 2 ni constant. So keluarkan 1 over 4. Variance y1. Okay, nak dapatkan variance y1, kaedah yang sama. Kaedah yang sama. Ni saya stop kat sini je. Nanti kamu cuba macam mana kita dapat expected value of y1 is equals to 2 theta. Expected of value of y1 square is equals to 6 theta square. Kamu dah ada ni. Kamu dah ada apa? PDF for y1 ni. Okay, now kamu dah dapatkan expected value of y1. So maksudnya kamu integrate lah expected value of y1 times dia punya density dia. Okay, maksudnya di sini nanti kamu buat y1 f y1 theta lah ya. So d y1. Dan dapatkan expected value of y1 square. Again lah y1 square times your PDF. Okay, ini dia punya jawapan dia. Okay, once you already get your okay, nampak variance dia. So variance y1 is just expected value of y1 square minus that one. So we get 2 theta square. That is your variance y1. So 2 theta square here. Kita dapatkan variance Vy1. You will get theta square over theta. Okay. Whereas, saya ambil kat sini ke? Okay. Whereas Vy1 kita adalah theta square over 2. Whereas y2 tadi, kita dapat theta square. So, of course, your variance Vy1 is less than theta square. Okay, so that means kita dah achieve lah. Kita dapat uniformly minimum variance unbiased estimator, which is your Vy1. Okay, kamu punya Vy1. Okay, which is this one. Vy1 kamu. Vy1, which is y1 over 2 is uniformly minimum variance unbiased estimator. Okay, because kita dah compare dia punya variance dia. So since your variance Vy1 is less than, so this is your uniformly minimum variance unbiased estimator of theta. So ini kita apply Rao-Blackwell theorem. Okay, maksudnya dia guide dia kamu punya solution tu step by step. First, dia dapatkan dia punya joint PDF tu. And then soalan dia show that y2 is unbiased estimator with theta, variance dia theta square, and then find expected value of y2 given y1. Dah dapat itu. And then baru kita selesaikan.